idea when we met. You guys have a general idea what the scientific method already is, and just go. You know, probably do kind of reinforcing maybe what a lot of you already know. And there's different ways to look at it. I think in the next slide, actually, I have, oh, I guess, new slide coming up. I thought I edited my slides. There's different ways to look at it. This is one way to look at it. It starts with, I think scientists are dreamers. Okay, a lot of artists are dreamers. They look at things and they wonder, now how does that work? And we're going to talk about, that doesn't necessarily lead them into the scientific method, but that's where it starts. They observe something, they come up with the best guess as to why that works the way it does, and then they come up with experiments to test that their hypothesis is correct, and then they kind of go from there. If the observation or the experiment says reinforces the hypothesis, then they kind of keep doing that for a while because you don't want to publish till you're pretty sure about it. And if you're pretty sure about it, you publish, and if the scientific community in your area agrees with you, it can be elevated to, starts letter T, theory. It can be elevated to theory, exactly. Just another way to look at the scientific method. Okay, so here I did blank these out, and I think maybe you have them. But what's, after observation and measurements, what do you come up with then? Starts letter H. Hypothesis, very good. Yay! Okay, after hypothesis, what do you do then? Starts letter E. Experiment, yes you do, very good. And then if you do this, you do this a lot, and if it continues to, experiments, your findings continue to support hypothesis, then you can elevate it to a theory. Perfect. Okay. I'm not to say I don't do it because I probably do, but you've heard the phrase, well, it's just a theory. Oh, no, if it's a theory that has actually come out the pike of this, it's no small feat. Okay. You can say it's just an hypothesis. And I actually went ahead and disconnected, this law. A law, sometimes theories can be elevated to laws. Laws are more fundamental. Laws are they just are. Like, for instance, some of you may know that if you take a gas and heat it up, and assuming that it's going to have the same pressure, the gas is going to expand. That's why, like, if you take a gas and cool it down, what will it do? Contract. Have you ever been, like, on these cold days, grabbed your water and your bottle of water, lid on it, and you go out to your car, and have you ever heard it kind of crunch? Okay, if it's cold and such like that, the gases in the headspace above your lid of water, the volume will decrease. Similarly, then you take that same bottle and you put it over here next to your heater, okay, and it expands. Sometimes it blows out. Anyway, the way gases behave with current temperatures is a part of the law. Theories would be take pieces of laws, and then theories come from after hypotheses, observations. A theory would be like the theory of, I just love this one. Oh my gosh. Sometimes I think it's because the older I get, the more I like history. Can you imagine looking at a map of the world, and what did they find when they started looking at the shapes of the continents? We could actually start to kind of fit together. And they actually found evidence, for instance, that in the Antarctic here, Antarctica, the continent of Antarctica actually fits nicely with, let's say, Africa. Then they can see like trail marks from glaciers. So anyway, that brings us to, and we hopefully will get to clear in Unit 5, the theory of plate tectonics. And this idea that that's a theory. Observations, expectations. Another thing I want to talk about then is what if the scientific method, we got that, right? Well, what is science? Okay. And I already told you that I have friends that teach psychology. Is psychology a science? Is psychology, I don't think it's a natural science. Psychology fell under what I'm thinking of kind of these different trees we looked at. Is math a science? Is astronomy a science? Yes. Is astrology a science? No. Astrology actually, and that's what this slide talks about. A lot of times we look at this, the ending of a word, O-L-O-G-Y, ology, and really that means the study of. But I like to tease that astronomy, you told me, is a science. Astrology is not a science. Astrology is like your horoscope. Not to say I'm not interested in it, but it's not a science, okay? So the kind of O-L-G-Y suffix has been stolen. I like to tease that when the science of astronomy kind of began to develop, astrology was already taken, so they had to call astronomy. Okay, so the thing about astrology, again, I'm a Sagittarius, okay? The thing about astrology is that it doesn't follow the scientific method. Now, there would be, and I'm not here to burst anybody's bubble. I totally am not into that. So, if you do astrology, that's cool. But it's not science. Okay. So, science in general, the fields of sciences need to follow the scientific method. You guys told me observations, hypotheses, experimentation. You loop it around, you can get to your hypothesis or theory. The other thing is that your science needs to be testable. And if we go back to astrology, it might be like, well, I read my horoscope and it was right. But that doesn't actually meet up to the rigor of one day that it was right. And that's usually pretty vague. But again, I'm not here to tell you not to look at your horoscope. Carl Sagan, bless his heart, he's passed away way too young. Carl Sagan did a lot for science. His field of science was astronomy. Some of you guys know. Carl Sagan had a passion for taking the science of astronomy and kind of meeting the public where they were. So he was great. And he said, I worry especially that the millennium as the millennium edges nearer, that pseudoscience and superstition seem year to year more tempting. The siren song of unreason more sonorous and attractive. I got that right. This class is not about, well, it's about physical science, but I just give a plug for the 50-some years I've been alive. I feel like science has been revered. You know, how awesome is that? These days we look at pictures, beautiful pictures of space, and we kind of take them for granted. So science then, I think, as far as being respected or understood, it kind of put the place it should be. That's just okay, pseudosciences. So astrology, the word pseudo means kind of, in this word, fake. So fake sciences includes astrology, cryptozoology. Actually, we have a great course being taught here, the science of monsters. That's cryptozoology. So basically, it's mythological animals. Not to say I don't watch things about Bigfoot, because I do. Another thing I watch, especially if it's late at night, I'm trying to look for something to watch, is stuff about UFOs. Ufology, not a science. Numerology, and that's an interesting thing too. How numbers really are infiltrate our lives. Okay, now science, even though they end in ufology. All right, so I've got 3 things here I'm going to show you, things that all point to it is a science. So sometimes science, like this slide says, is harder than you think to identify, to put your finger on. If you've ever heard of the KISS principle, keep it simple, right? silly, not silly. Keep it simple, silly, kiss. Kiss back. One of the cool things about science is that, one of the cool things about science is that simpler, how do I say this? If your hypothesis is has too many details, too many ins and outs, too many things that can go wrong, then your hypothesis probably has an error. If you have to keep adding on to what's going on behind the scenes to make it agree with your observations, keep it simple. Okay. Another one is that it needs to be verifiable. Verifiable. Again, we're back to kind of the experiment parts. Okay, can you, for UFOs, can we create an experiment and anticipate collecting the data? Oh, that's I watch those TV, or my daughter does. I watch when she has it on. Those things about the ghosts and the hot spots and the cold spots. That would be trying to make the whole ghost thing verified. Although I love watching. So it needs to be verifiable. And the last one, and I'd be glad to kind of talk to you outside of class, but in your hypothesis, in your details of how something works, they have to be natural. They have to be something that we can see. Now, I believe in the unnatural. I'm a Christian, blah, blah, blah. And I should say blah, blah, blah. I take it seriously. So I think there are unnatural things that are happening, but that's not science. Okay. All right. So I don't know. I kind of mentioned I have calculators. So if you have a calculator, you might want to be kind of dragging. Anybody want to borrow a calculator? Sometimes phones can work as your calculator, but I think that gets a little tricky too. Oh, the thing about the calculators is you're going to need to be able to do scientific notation here. Yeah, and do you guys remember I put up those 5 different sciences, okay? And which 2 sciences have numbers? Physics? Great. But there will be some numbers that you'll be able to correct, okay? So one of the things in this day and age, even though I think that science isn't elevated like it should be in society, our society, and other societies. But a good thing about where we're at in history is that across the world, we scientists have decided on a few things with regard to measuring quantities. So this idea of an international way to measure things, or an international unit for measuring things, I'm all for that. Going to school when I was like in 5th grade, I can still kind of remember this, because I was like, you believe everything the teacher tells you in 5th grade, right? So I can remember my teacher saying, we're going to talk about the metric system today, girls and boys. You need to listen up, because when you are adults, putting gas in your car, like putting gas in your car, I don't even know how to drive. When you're putting gas in your car, you're going to be putting it in liters. Liters is metric, gallons is English. So you're going to use the metric system. And I still put gas in my car using gallons. Okay, so anyway. But in this class, we're going to kind of focus on the metric stuff. Okay, so. But unit-wise, if I were to ask you to go to the lab and weigh something, you would come up with a mass. Now, there's a subtle difference between weight and mass. We're going to kind of probably use them interchangeably. Weight actually has to do with the gravity of the Earth pulling on that object that you're trying to measure. Okay. Mass has to do with how heavy it's on. So there's a subtle difference, but we'll kind of use them interchangeably probably. I could ask you in the lab, or you might need to convey to somebody across the world what sort of time it took for something to occur, okay, and we have length. Now, this table right here is, in the international sense, what units do we use in science? It's kind of fun to think, like, before there was the communication that we have today, it makes sense that people in different countries had different units of measurement. Like, take length, for instance, okay? They wouldn't know what a foot is, okay? And actually today we don't go with feet. Of course we go with meters. It's our basic unit, okay? kg stands for kilograms. This sometimes I make this a test question, because if I were to ask you what the metric unit for mass is, you would probably tell me grams. But when it comes to science, the basic unit is not just a gram, it's a kilogram. Temperature, if I were to ask you what temperature today, what units would you probably use? Like, what's temperature outside? Of course, you're probably familiar, we have a Fahrenheit temperature scale, we have a Celsius temperature scale. And if you think Celsius is metric, you're right. And then even a cooler, no pun intended, more awesome temperature scale off of Celsius is the Kelvin temperature scale. We'll talk a little bit about that later. When I talked about mass, I said how many atoms there are, and actually we talk about how many atoms in terms of something called mole. We'll talk about in chemistry. Electric current is the ampere, time is the second, and how bright something is the those are the base. Those are, internationally speaking, the basic units of science. So this goes back to my teacher. It's like, remember I said that she's like, oh, you're gonna pump your gas on gallons and liters. Well, this actually is a speed limit sign, I think in Canada, where they have the speed limit in miles per hour and the speed limit in kilometers per hour. That's kind of cool. A lot of times the cars you buy anymore have the dual system on that. Or you can change it if it's like a digital. Oh my gosh, all these prefixes. Make it go away. Well, the prefixes I need you to know are the 4 over there on the far left. See if my pen works this morning. So I need you to know kilo, and kilo is right here. I'm going to go, yeah, it says 1,000. 1,000 times, okay? I need you to know centi, and centi is smaller than the base unit. It's 1/100th. The symbol for centi is C. I need you to know milli. What's the symbol for milli? M, yep, here. Milli is smaller than centi. It's 1/1000th, and we do 1/1000th as 0.001. And I need you to know micro. Micro is even smaller than milli by actually 3 more zeros. So right under milli, you see micro. So it's 0.000001. And I disagree. I can see, I'm going to put an X through that M, because how could you have 2 metric prefixes with the same? So instead of M, it's a Greek letter mu, and mu looks like this. I'm going to make it bigger than the M. It looks like a U. Here's my U, but it has a tail on the front end. That is the Greek letter mu, and that's the prefix for micro. I just now thought about this. I wonder how many years I've been teaching this. I think you have room to jot this down if you want to. You can put it over there by the things. So how does this go? Well, 1 kilometer is equal to how many meters? Okay, so 1 kilometer is equal to 1,000 meters. That's how that goes. You can say 1 kilogram is equal to 1,000 grams. 1 kilosecond is equal to 1,000 seconds. You can switch it up. All right, let's take the next one, centimeter. Let's go with, well, let's stick with meters. So 1 centimeter, following the same pattern, 1 centimeter is equal to how many meters? Which is bigger, centimeter or meter? Meter's bigger, yep. So does this make sense that if you have 1 centimeter, you're not going to even have a whole meter, you're going to have a fraction of a meter. So according to this pattern, 1 centimeter is equal to how many meters? Yep. So 0.01, you guys buy this, that is 1/100. Does that work for you? Same thing. Well, usually I don't think of it in terms of this way, between centimeters and meters. This is how 1 meter is equal to how many centimeters? That one? 20 meters bigger, one of those, centimeters are smaller, how many centimeters? If you have $1, how many pennies do you have? That's going to the cents keeper. So 1 meter is equal to 100 centimeters. And it's easy when you're working problems in science to get it mixed up. I know there's a 100, 100. Any questions about that? So these two are right. So let's go ahead and do milli. We'll stick with meters if that's okay. 1 millimeter is equal to how many meters? Yep. 0.001. And what does that number mean? 1,000. So you know where I'm going with this. If you have one honking big meter, how many millimeters do you have? Yep, 1,000. Perfect. I'm liking it. Last one we need to tackle is micro. So 1 micrometer, sometimes called 1 micron, 1 micrometer is equal to how many meters? Yeah, 0.000001. I'm liking it. And that decimal number is 1 million. And 1 million is got 6 zeros. Okay, so you know where I'm going. If you have one big long meter, how many micrometers do you have? 1 million. 1 with 6 zeros. I'm going to put one more word up to kind of describe these. These have, what's this mathematical symbol? Equal sign. Yeah, equal sign. We call these equivalency, equivalency statements. All we're doing is kind of saying. So those are the 4 I'm going to hold you accountable for. Okay.
Scientific notation, people. How many people in here are kind of like, I've done scientific notation, so I kind of get it. Okay. Just because you don't say, I don't know, I can't read this group yet, so, okay. So scientific notation is great for things like that have a lot of zeros. Okay, this would be a big number. It's also great for numbers that have a lot of what we call placeholders. Like, it's great for small numbers. If I write over here, can you guys see it? Okay. So, 0.00000001. I mean, that's annoying. So scientific notation is great at packing that up too. So if the number is big, well, first off, with this big number, oh my goodness, I don't even know, is it a trillion? So we have, let's see, a million would be here, a billion would be here. You're looking at 12 trillion, 300 billion-ish. Where's the decimal there? At the end. Yep, you guys would tell me the decimal is right here. Sometimes I call that an implied decimal because we just all know it's there. So if you guys have done scientific notation, you already kind of know where I'm going with this. What we do is we find the decimal and we move the decimal so we get a number between 1 and 10. And in this case, the number is going to be 1, 2, 3, 4, 5, 6. I'm counting as I move it. 7, 8, 9. I'm going to move it one more place. So my number between 1 and 10 is 1.23. 1.23. And the number of places I moved it was 3, 6, 7, 8, 9, 10. I moved it 10 places. So 1.3 times 10 raised to the number of places I moved it, which is 10. And this is how I think of it. The fact that it's a small number means my exponent of 10 is going to be negative. You can read that. 1.23 times 10 to the negative 10. That's packing that thing up. Okay. Good with that? All right. How about a small number? Where's the decimal here? Yep. It's actually not implied. It's there. It's explicit. No, you've got to know that the decimal's there. Okay, in this case, to get a number between that's less than 10, I'm actually going to move the decimal so it's right after the 4. So it's going to be 4.721. So see how many places I move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm moving it 9 places. And the first part of the number is going to be 4.721 times 10. Oh, did I put that? Are you serious? No one corrected me. Times 10 to the raised to the 9th power. You guys let me get by with that, didn't you? I'm sorry. Okay, this is a small number. So that 9, I'm going to put a negative in front of it. Oh. You guys are like, what is this, Friday? Okay, so I'm going to need, okay. Let me revisit this up here. It's not a small number, it's a big number. So what should that power 10 be? Positive 10. And I can fix that. No one will know. That's a pause there. Okay. Sorry about that. But otherwise, it's right. Okay. So this is actually these bullets 1 through 6 now is what we just did. We found the decimal, we moved it to, I get my left and rights mixed up. We moved it to, for the big number, moved it from right back to left, and exponent of 10 is positive. And then for the small number, we moved it left to right. So we got a number between 1 and 10, and our exponent is negative. Fine lines. I'm pretty sure Shipment has in the back, in the appendix, it has like some extra help with this. If you have any question. Okay. Actually, I'm going to put you guys on the spot. Okay, so you can see the next slide. Go ahead and take a minute and it's not and you can kind of work together or whatever. Oops, sorry. Also saw the moon this morning. It was beautiful. This is the one I messed up. Yeah. You guys are going to have to get better at telling me when I make mistakes. That's a 4. Can't read my writing. Anybody see anything there? You're like, are you sure about that? All right. Cool. All right, so here we go. Now, working problems and such, and this class isn't just about working problems, but we're going to work a few problems in physics and chemistry, like I said. What works well is you have two numbers to be multiplied by each other. A lot of times we'll put them in parentheses. Like if I wanted to take this number times 21, I would just put this number in parentheses, begin a new parentheses, and put 21. That's just how we do it. So the fact that I have two numbers in parentheses next to each other, that's just to multiply. Okay, so that's what that means. I don't know why we do that, but that's what we do. All right. All right, so grab your calculators. And for the ones who borrowed a calculator, I think it's an EXP. You should find an EXP, an SCIP, a 10 to the X. A little bit different. So I think what we'll do is just kind of find our way through this, if that's okay with you. Now, before I kind of turn you loose, there's one last thing I want to do, and once you're done with that, you can leave. I want to tell you that what the assignment is, okay? So there is an assignment that's due on Monday. And yeah, I don't think my PowerPoint slides have these, do they? So you're going to want to jot this down. I will also put this out on Twitter. So this isn't in the notes I gave you. Just kind of the way it's working right now. Maybe I'll try to fix that. But I'm going to go ahead and take you out to the textbook. That's what that blue link is for me. And kind of show you on page 23 and 24 what those problems look like. Now, I can't assign anything to you until we talk about it, right? So those problems must be related to what we've already talked about. So again, I'll post this on Twitter. Pages 23 and 24. They will be short answer 1, 2, 19, and 21. And this is what it should look like in your textbook. In theory. Let's go one more. All right. So short answer down here, these are things we talked about. What is, I know it's hard for you guys to read, but what is definition of science, 5 major divisions, what was it, 9? Was it 1, 2, 9? 19. Okay, thank you, 19 and 21. Okay, looks like those two. So if I go to the next page, there should be stuff you can answer. What are the 4 most common metrics prefixes? 21, what's the standard unit of volume in SI system? I'm not sure it was on my slide. I might have to do a little bit of research. Those will be due. Now, none of those have anything to do with the last slide I've got. So here's my last slide. So what I'm going to do is, do you guys have this slide? Oh, good. So go ahead, I know we're bumping up against time. I'm going to go ahead and write the answers up there. And we might pick up, we'll pick up here if we have any problems, which I'm not sure they're necessarily problems, but we'll pick up here on Monday. So for the first one, I got, and if you didn't quite get this, like I said, we're going to kind of play around with it Monday, but if you did get it, looking pretty good. I'm going to give there what we call 2 significant figures in the coefficient. This first part's called coefficient. So I got 3.1 times 10 raised to the 20th power. Did anybody get that? Well, that's the right answer, though. Okay, and I'm gonna, again, I feel bad to kind of leave you on a hanging, but we'll bring these up when we meet on Monday. The next one you should get and this is actually something you can take home and say, keep working it till you get this. So I'm going to give this next one what we call 3 significant figures. So I'm going to round it to 1.73 times 10 to the negative 20th. And last but not least, to give me 2 sig figs, I got 2.2 times 10 to the negative 34th. So you might want to jot those down. Anybody get all 3 of those? Anybody get 2 of those? Anybody get 1 of those? Okay. But in general, what you'll do is you'll put in the decimal number, you'll hit your EXP or your SCI key, and then you'll put in the power of 10. Oh, see, you guys don't admit when you get them. Okay. So that's all I have today. And we'll get it again on. Now, I do check my email over the, I know another thing I can tell you. is I'm going to give you guys 10 extra credit points for science if you, and you're going to have to speak into it too, change your picture in Canvas.
Oh, I did mine.
You did, you got it then. If you already have it, you're getting 10. If you already have yours, you're getting 10. To change the picture in Canvas, all you got to do, it's not very hard. To change your picture in Canvas, oops, that's not my Canvas. You go into, see how my pictures looks like that? All you got to do is go in accounts, and you can do it a couple different places, but if you go into settings, you hover over your picture, and you'll see a pencil. You click there, and that's how you change it. That's it. And you'll upload a picture. And it doesn't have to be you. It can be your dog or whatever, but it's under account and settings. All right? 10 extra credit points. But like I said, if you all max out with your assignment points, you can't get more than 100%. I did that last semester. It's fun, but okay.